All right, so let's continue with our small data set. Data set of 2,000 samples, 1,000 pictures of a cat and 1,000 pictures of a dog. And we've looked at one way how we can deal with this small data set and actually create new data. Yeah? So that is called data augmentation. Basically what you do is you slightly transform the pictures that you already have, right? You turn it, you rotate a bit, or you stretch it a bit, so that the machine thinks that these are new pictures. Yeah? So we've done the exercise on our cat and dogs data set, and we've seen that there is some improvement, yeah, but not too satisfactory. Yeah? So you avoid overfitting. The problem is, however, that your accuracy is not where you need it to be, especially if you run 30 epochs. Yeah? Now we've seen that when we increase the number of epochs to 100, we break the accuracy ceiling of 82%. Yeah? So now we're going to take a look at another way of dealing with a small data set, and that is using a pre-trained cognate. Yeah? Pre-trained means that you use an existing cognate that has been trained on ImageNet. Remember, ImageNet is a series of 1.4 million high-resolution images, and there's about 1,000 classes. Now, cats and dogs are part of these 1,000 classes. Pre-trained, so they're existing, and the great thing is that they're actually incorporated in Keras. Yeah? So it's not so difficult from a coding point of view. So these are some of the pre-trained networks that are available in Keras. We have Exception, we have Inception v3 from Google, then we have Restnet 50, yeah? And Restnet 50 is the pre-trained cognate that we will use. Yeah? Why is it Restnet 50? Because Restnet basically has 152 layers, which is a very deep network. But it says 50 because we're going to use the first 50 layers as a convolutional base. So, in terms of working with a pre-trained cognate, there's two options. You can use feature extraction. Yeah? So that means that you're going to use features extracted from your convolutional base. Here I just quickly draw the cat and dogs exercise that we're going through. You have color images of 150 by 150 by 3, and then we have 4 convolutional layers, then we have a flattening operation, and then we have a fully connected layer here. Yeah? So basically what you're going to do is you're going to keep the convolutional base, but you're going to change the fully connected layer. Yeah? And basically you're going to retrain that layer, and also you're going to do new weight initialization. Now here with Restnet we only take the first 50 layers and not the whole block of 152 layers. And why is that? Well, if there is a nice connection between the classes your pre-existing cognate has been trained on, then it's okay to take all the layers. Yeah? But when the relation is not so good, yeah, then it may be more interesting to take the first few layers. Yeah? Because we know that the first few layers, they're gonna detect local features like edges and so on. Yeah? Once you go further and deeper into the network, you take more abstract features, yeah, like the eyes or the nose or the head of a cat and so on. So you might not be willing to go that far. For example, if your convolutional base doesn't really have cats and dogs. Yeah? If one of these 1,000 classes would not be cats and dogs, or at least animals, you may want to use only the first few layers. Yeah.